Children, listen. In 9th standard, you studied set language. Just I am going to give some introduction on that. What is set, type of sets, the operations that we are going to discuss. A set is a well-defined collection of objects. You know that. Well-defined means we should have the certainty that whether that particular element is in that set or not. See, for example, collection of natural numbers. Suppose I am saying -5, you'll say that it's not in that set since it's natural numbers. If I am saying 10, you'll say it's in that set. Am I right? Which will be in that collection. Like that, if I am saying 0, you'll say that which is not a natural number. Therefore, there is a certainty is there whether that particular element is in that collection or not. Therefore, collection of natural numbers, it's a set. Okay, children? This is a set. Collection of English alphabet. I am saying alpha. Alpha is not a English alphabet. Clear, children? Alpha is not an English alphabet. So I am saying Z. It's an English alphabet. So like that, we should have the certainty that whether it's in that collection or not. Therefore, we can say that it's a set. Next, collection of good students. See, the word good is not defined. Okay, children, which will vary person to person. Therefore, we are saying collection of good students is not a set. It's not a set. Clear, children? So, a set is a well-defined collection of objects. Next is types of sets. A set consisting of no element is called a empty set or null set. Empty set means there is no element. Next is singleton set. Single, the word itself which says only one element. Finite set, finite number of elements. Infinite set, say for example, infinite set example, natural numbers. Natural numbers, it starts from 1, 2, 3, etc. This is an example for infinite set. Clear, children? Two sets are equal. Okay? Two sets are said to be equal if they contain exactly same elements. Otherwise, they are said to be unequal. For example, there is a set A. A is having 1, 2, 3. B is another set which is having 3, 1, 2. Both are same elements. Am I right? Therefore, we can say that A is equal to B. Clear, children? Then, important one is universal set. A universal set is a set which contains all the elements of all the sets under consideration and is usually denoted by U. This is known as universal set. Set operations, we must know. Complement of set, that we used to denote by A dash or A power C, which denotes complement of set. The set contains elements from the universal set but not from A. That is symbolically it's given A dash is equal to set X such that X belongs to U but X does not belongs to A. Just I am giving one example. Let the set A is equal to 0, 1, 2, etc. Okay, children? Okay, I'll take this as a universal set. This is the universal set. And A is equal to 1, 3, 5, etc. This is set of all odd integers. Suppose A dash means except A elements. That is 0, 2, 4, 6 and so on. So this is complement of A. Next is union of two sets. The union of two sets A and B is set of all elements which are either in A or in B or in both. Okay, children? So we have to take the elements from A and B. Intersection of two sets. That is, the elements common to both A and B. That is intersection. We used to denote by this symbol A intersection B. Then difference of two sets. That is A difference B, that can be denoted by this symbol or this symbol. Okay, children? So that is the set of all the elements from A but not from B. Are you clear, children? It should be from A but not from B. That is only given in symbol A difference B is equal to X such that X belongs to A and X does not belongs to B. B minus A means it's from B but not from A. Make it very clear. Now we are going to discuss one problem to find all these things. Let A is equal to A, C, D, F. B is equal to B, C, E, F. Okay, children. Now we can find A union B. Listen carefully. A union B means you have to write the entries from both the sets. That is, you have to collect all together A, B, C, D, E, F. All the entries you have to put together. Then A intersection B, which means common elements. Here the common elements are C and F. Okay, children? These are the common elements. Therefore, we are getting this is C comma F. It's intersection. It's common for A and B. Common from A and B. Next is A difference B. A difference B. It's from A but not from B. Therefore, we have to take off the elements from A. Common elements from A. That is, except the common elements C and F, we have A and D. Like that, B difference A. The answer should be from B now. Just you have to remove the common elements. That is, C and F you have to remove from B. That is, except that rest of the elements is B comma E. Clear, children? And suppose the universal set is equal to A, B, C, D, E, F, G, H. Okay, children? Now A dash, already we discussed now. A dash is equal to U minus A, except A elements from U. Now we can list out the elements. You have to take off the elements of A from U. B, E, G, H. Okay, children? Suppose B dash and B dash is equal to, that is U minus B, that is A, D, G, H. These are the elements in B dash. Clear, children? Next, some properties we are going to discuss. Properties of set operations. Commutative property. For any two sets A and B, A union B is equal to B union A. and A intersection B is equal to B intersection A. So you must know that commutative law is true in union of sets and intersection of sets, but it's not true in A minus B is not equal to B minus A. Clear, children? That just we discussed now. That is A minus B we obtain and B minus A we obtain here, which implies it's very clear that A minus B is not equal to B minus A. Clear, children? Then associative property, for that we used to consider three sets. A union B union C is equal to A union B union C. Second property in terms of intersection. A intersection B intersection C is equal to A intersection B intersection C. Okay. Like that, A minus B minus C is not equal to A minus B minus C in general. Distributive property. For any three sets A, B and C, first one, A intersection B union C is equal to A intersection B union A intersection C. Second one, A union B intersection C is equal to A union B intersection A union C. Just you recollect the De Morgan's laws for set difference and complementation. First one, A difference B union C is equal to A difference B intersection A difference C. Like that, A difference B intersection C is equal to A difference B union A difference C. Just you remember these laws, which will be useful while doing the sums. Next is De Morgan's laws for complementation. That is, A union B whole dash is equal to A dash intersection B dash. And the second one is A intersection B whole dash is equal to A dash union B dash. Clear, children? And some results you have to recall. If A and B are two finite sets, then first one, n of A union B is equal to n of A plus n of B minus n of A intersection B. Second one, n of A minus B is equal to n of A minus n of A intersection B. Third one, n of B minus A, that is equal to n of B minus n of A intersection B. Fourth one, n of A dash is equal to n of U minus n of A. Then for any three finite sets A, B, C, n of A union B union C is equal to n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C. Just you remember all these things, then you will be comfortable to learn the 10th standard portions. Now we are going to discuss the 10th standard topic. Now we are going to discuss the 10th standard portion, that is relations and functions. This is the first topic. For that, we are going to say some different definitions. That is, first one is Cartesian product. If A and B are two non-empty sets, then set of all order pairs A comma B such that A from A and B from B is called the Cartesian product of A and B. It is denoted by A cross B. Thus, A cross B is equal to set A comma B in order pair such that A belongs to A comma B belongs to B. Okay, children. Now we are going to discuss how we can obtain A cross B. Let A is equal to 1, 2, 3 and B is equal to 2, 3, 4. Okay, children. Now, A cross B, which is equal to 1, 2, 3 cross 2, 3, 4. This is equal to, first you distribute 1 along with the B set elements. That is 1, 2, 1, 3, 1, 4. Then you distribute 2 along with B set. That is 2, 2, 2, 3, 2, 4. Next distribute 3, 3, 2, 3, 3, 3, 4. Okay, children. Then you find B cross A. Now B is the first set. So we are taking 2, 3, 4 cross 1, 2, 3, which is equal to, you distribute 2 along with A set elements. That is 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. Next is 4, 1, 4, 2, 4, 3. Now we obtained A cross B and B cross A. Here A cross B is not equal to B cross A. Why? Here we have 1, 4. Here we have 4, 1. Both are not equal. Since 1, 4 is not equal to 4, 1. Are you clear, children? Some elements may be equal, but not all. But you must know n of A cross B equal to n of B cross A. Since n of A cross B is defined as n of A into n of B. In A we have 3 elements. In B also we have 3 elements. Altogether 9 elements. The same thing, n of B cross A means n of B, that is 3 elements. N of A is 3 elements. Totally we have 9 elements. Therefore we are getting n of A cross B is equal to n of B cross A. But in general, A cross B is not equal to B cross A. This is for 2 sets. Cartesian product of 3 sets. If A, B, C are 3 non-empty sets, then the Cartesian product of 3 sets is the set of all possible ordered triplets given by A cross B cross C is equal to set A, B, C is the order pair for all A belongs to A, B belongs to B and C belongs to C. For example, let A is equal to 1, 2. B is equal to A, B and C is equal to alpha. Now A cross B cross C we have to find out. For that 1, 2 cross A, B cross alpha, which is equal to, first I am going to take cross between first 2 sets. That is 1, A, 1, B, 2, A, 2, B. Clear, children? Cross alpha. Now we have to take along with the C set. Therefore, we are getting set 1 A alpha, 1 B alpha, 2 A alpha, comma 2b alpha. Clear, children? This is A cross B cross C.